Hi, so in this video we are going to look at surds. We are going to look at multiplying and dividing them to start with and looking at the main rules, a little bit of adding and subtracting, and then some multiplying out of brackets. So just a bit of an introduction. Rational numbers are numbers that can be written as a fraction, like a over b, where a and b are integers or whole numbers. Irrational numbers can't be written as a fraction. The decimal form of an irrational number doesn't terminate or recur. So pi is a good example of an irrational number because the decimal version goes on and on and on, but it doesn't ever have a pattern that repeats. So a surd includes a root symbol, such as root 2, and they are used to write irrational numbers precisely. So we'll start off by looking at multiplying and dividing surds. So two main rules you need to know. The first one is this: the square root of a times the square root of b is the same as the square root of a times b. The second one is similar but with division. So the square root of a divided by the square root of b is equal to the square root of a divided by b. So a couple of examples. Root 3 times root 5 is the same as root 15. And root 10 divided by root 2 is the same as putting the 10 divided by 2 in a bracket and square rooting all of that, which gives us the square root of 5. This also means, and sometimes you see this rule written down too, that if you square the square root of a number, you end up back at that number. So for example, if you square the square root of 5, the root 5 times root 5 is 5. So some examples. If you are asked to calculate root 3 times root 7, we use the multiplication rule and we get root 21. Second one, if you're asked to calculate root 24 divided by root 6, we follow the rules. So we put 24 divided by 6 together, which gives us the square root of 4. And we know the square root of 4 is 2, so that's the answer. So this is a slightly different type of question. In this question, we're asked to simplify. So we are going to look for factors of 12, where one of those numbers is a square number. So we know that 12 can be made up from 3 multiplied by 4. So if we write root 12 as root 4 times root 3, we can then replace that root 4 with 2 and multiply by root 3 still, which gives us 2 root 3 when we take out the multiplication sign. And another similar one, if we're asked to simplify root 50, we're going to look for those factors of 50 where one of them is a square number. So as we know that 25 times 2 makes 50 and 25 is a square number, we can rewrite it like this. And then we know the square root of 25 is 5. So 5 times root 2 we can rewrite as 5 root 2. So root 50 simplified is 5 root 2. And another one, so simplify root 72. So can you think of factors of 72 where one of those numbers is a square number? So root 9 times root 8 is the same as root 72. And we can square root 9 to give us 3. But in this one, we can even take the root 8 down a bit further because we can split root 8 into root 4 times root 2. And we know the square root of 4 is 2. So this gives us 3 times 2 times root 2, or 6 root 2. And this one combines a bit of both of the things we've been looking at so far. So we're going to start off. This is a calculate. We're going to go back to the beginning and we're going to multiply those two numbers together to give us root 48. But then we're going to actually break this down. So again, look for those factor pairs where one of the numbers is a square number, which is 16. And so we can rewrite it as root 3 and root 16, and we know the square root of 16 is 4, so that turns into 4 root 3. So we're going to have a little look at adding and subtracting with surds. There aren't specific rules in the same way there are for multiplying and dividing, but what we can do is break them down so that hopefully we have similar parts that we can add up together. So same kind of thing, we're going to start by breaking down the root 12 into root 4, root 3, because 4 is a square number. We can break root 27 down into root 9 times root 3, because 9 is a square number, and then rewrite those, which gives us 2 root 3 plus 2 lots of 3 root 3, which is the same as 2 root 3 plus 6 root 3. And because we've got 2 of something and 6 of something, we can add those together to give us 8 of something, which in this case is 8 root 3. So finally, we're going to look at multiplying brackets using surds. So here's an example. Do you remember when you get a bracket and you square it, you have to write the bracket out twice? And we're going to use FOIL or whatever method you want to use to multiply out all the parts of the brackets to give you 4 different parts. So the 5 times 5 gives you 25. The green, 5 times root 2 is 5 root 2. The blue part is again 5 root 2, and the orange part, the orange arrow, is root 2 times root 2, which if you remember gives you 2. So if we collect those up, we've got 25, we've got 5 root 2 plus 5 root 2, which gives us 10 root 2, and the root 2 times root 2 gives us 2. And then we can collect up the 25 and the 2 because they're like terms, and we've got 27 plus 10 root 2. So the final example, another one with brackets, but this time different numbers in each bracket. And similar kind of thing, we're going to multiply out using FOIL in this case. So the first 2, we've got 1 times 2, which is 2. We've then got the purple ones, 1 times minus root 8, which gives us minus 1 lot of root 8. We've then got root 3 times 2, which is the blue. And the orange, we have got root 3 times minus root 8, which gives us altogether minus root 3 times root 8. So then we can collect those bits up to give us 2 minus root 8 plus 2 root 3. I've just swapped the order of those numbers around, and minus root 24, because 3 times 8 is 24. And then I have rewritten the root 8 as root 4 root 2, and I've rewritten the root 24 as root 4 root 6, because 4 is a square number in both those cases, which then means that I can break it down even further to 2 take away 2 root 2 plus 2 root 3 take away 2 root 6. So practice those type of examples until you become confident with them, and then once you are, you can move on to the next video, which is rationalising denominators. See you then.